Alright class, we're going to continue solving radical equations. Basically the same thing applies. Isolate the radical parts and then solve. So if you're looking at number 1, there's two pieces with radical parts. Now the thing is, you do not want to square it now because then you'd end up foiling because you have two pieces on one side. So again, you still want to isolate the roots. So we're going to say the root of 12 minus 2x equals 2 root x. Now we can square both sides. And you get 12 minus 2x is equal to 4 and then x. So you get 6x is equal to 12 and you get x equals 6. Alright, just double check. You get 12 minus 2 times 6 is 12, so that's a 0. Minus, wait, no, that's not correct, is it? 12 minus 4, or I can't divide, guys, sorry. X is 2, and that's what I have to be careful. But obviously checking my answer showed me that I was not correct. Okay, because it didn't make sense. So let's do it with 2 now. 12 minus 2 times 2 is 4, so that would be root 8 minus 2 root 2. And root 8 is 2 root 2, so that equals 0, so that checks out. So the answer is 2. Okay, second one. And that is why, again, it is important to check your answers. Here we have 3 radicals. Now, if we move a radical over here, it just makes it messier, so honestly we have to just square it on this side, the way it is. The problem with that is we're going to have to FOIL the left piece. So if I FOIL this left piece, I'll do that by hand because it's a little bit weird. And that just becomes x minus 6. So root x times root x is just x. Minus root 6x minus root 6x plus 6. So we basically get x minus 2 root 6x plus 6 equals x minus 6. These x's go away. Subtract x, subtract x. This 6 goes over here and you get negative 12. Divide by the negative 2 and you get root 6x is equal to 6. We square both sides because now we have a root that's isolated again. And we get 6x is equal to 36, which means x equals 6. Make sure to check your answer. If I put a 6 in here, root 6 minus root 6 is 0, yes. And if I put a 6 in here, 6 minus 6 is 0, yes. Alright, so that is isolating and then squaring. So these are actually review problems. This is, if you have an x in the exponent, you have to get the bases equal. So this is already base 3. This turns into 3 cubed. Remember, when you have power to a power, you multiply. And now that the bases are equal, we can set these equal. So x equals 9/2. If you plug 9/2 in your calculator, it should work out. Okay, you can do a few things on this one. We have a base of 11 equal to the negative x. We have this. So clearly if it's base 11, this is going to be 11 to the something. And if you use your calculator, you can figure out that 1331 is actually 11 to the third. However, we need to move the base up to match it with this one. By moving it up, I change the power to negative 3. Now my bases are equal. Now I can set these equal. And you get x equals 3. Which makes sense, because if I put a 3 in here, it'll move it down. You have 1 over 11 to the third. So that is our answer for that. And then finally, this one is a little trickier. We need to get a common base. Well, we have a lot going on here, so we need to make everything 2's on this side. 16 is 2 to the 4th times, this is 2 squared, and then that means it's to the 1/5. Okay, so we have 2 to the 2/5 and 4. You have to add those fractions together. So 4 plus 2/5. So that's times 5 times 5. So we get 22 fifths. So this becomes 2 to the 22 fifths equals 2 to the x minus 3. Now that we have the bases the same, we can say x minus 3 equals 22 over 5. So x is equal to, when you add 3, that'd be 15 more on the top, which is 37 over 5. And if you plug that in, it will equal. So that is the answer. Okay, so that is just more practice. On the back we have a little bit of review for find each composite and state the domain. Again, I'm going to rewrite these so I can look at the domains. This is the square root of x, so x can be greater than or equal to 0. Here it's 3 over x, so x cannot be 0. So f is 3 over x, so I'm going to do 3 over, and then instead of x, I'm putting in 2 root x. Okay, because that whole thing is to the negative power, so it goes down. But I want to rationalize this, so I'm going to multiply the top and bottom by root x. So I get 3 root x over 2x. So now remember, with composite, it's the input, which is this, and the final. Well, the final is you can't have negatives, but you also can't have 0 now, because we have an x on the bottom. So x has to only be greater than 0 for this problem. And if we go backwards, and we do 2x to the negative 1/2, I'll do it this way. There's a lot of different ways you can do it. I'm working with powers here. This becomes 2 times 3 to the 1/2 times x to the negative 1/2. So that stays up. So I'm going to write it now in terms of radicals. So we have 2 times root 3 over, this goes to the bottom, becomes root x. I have to rationalize. And I get 2 root 3x over just x. And again, the input is that x can't be 0, but if you look at the final, that's still the case, but we also now can't have negatives. So that the domain is still, again, in this case, just greater than 0. Okay, so a lot of review today. We have a test in 2 days from now, so just keep working at these worksheets and get ready for that test.